Good morning. So the first thing we're going to do is we're going to look at two problems from your homework on a Friday. That was the section 4.4 practice worksheet. And then we are going to continue working on factoring, but in application problems. So we're going to look at a few application problems today. So then looking forward, tomorrow we are reviewing section 4.3 and 4.4, which is factoring, and then the application problems that we do today. And then you will have a quiz on Wednesday on these two things. So we're going to do application problems today, review tomorrow, quiz Wednesday, and we'll talk more about the quiz tomorrow. Questions about this week? All right. Oh yes, everyone at home, make sure you're taking your daily attendance. It's at the top of Google Classroom, the top of the Google Classroom page. When you are virtual, you must take your daily attendance every day. Okay?
So those of you that are in the room no longer have to take attendance when you come to school. We are now taking attendance. But when you're home on Wednesday, Thursday, Friday, then you would take attendance for yourself.
Makes it easier. All right. So take out that homework. Let's look at number 27 first. I'm just going to rewrite it over here to give us some more room. So we have 5x squared minus 3x plus 3 equals negative 2x squared plus 3. What do we have to do first? Jordan, what do we have to do first?
Get 0 on the side.
Yeah, so let's bring everything over to the left. So when we add 2x squared to the other side, we would get 7x squared minus 3x. And then since it's being added on the right, I'm subtracting. So then 3 minus 3 is just 0. So once we bring those terms to the left, that's what we would be left with. Now what should we do? Think.
I took x out.
Yep.
So minus 3.
Awesome. Yeah, remember that cheat sheet? The first thing you have to do once you have it equaling 0, you got to take that GCF out. And we can't do anything else to this 7x minus 3. So this is completely factored. Now, what should we do to solve? Riley?
Did you just distribute?
So we're not distributing because we want it in this factored form. We're going to do something with the different factors. Put this 0. Remember the zero products property? What did that tell us? It allowed you to set each factor equal to 0. So we're going to take this x and set it equal to 0. And then we're also going to take this set of parentheses and set it equal to 0. So this, we know x is 0. We know x could be 0. And then x could also be what? Leah? We'll add that 3 over. And then what do we do? Yeah. So x could be 0 or 3/7. Yep. Questions on this one? All right. So now let's also look at 31. So there are also questions on 29. Looking at 29 real quick, we see 3x squared plus 2x. What would we do there? Okay. Yeah, take out that x. So just like how we just did, you have to take that GCF out. So 29 is just like 27. All right, and now let's also look at 33. So we have 3x squared minus 9x minus 24. What should we do first? Jordan?
Well, I substituted the f of x as 0 first, and then once I did that, I took out 5. Oh, and 33, sorry.
Okay, yeah. 33.
Then I took out 3.
Yeah, good. So when you take out that 3, what are you left with?
11x squared minus 3x minus 8.
Good. We know that's being set equal to 0. So now what do we do with that quadratic on the inside? Faith?
You find with 11 times 8 is equal to, and that's negative 88. And then the two factors that go into it to equal negative 3 is negative 11 and 8.
Perfect. So we need those factors to add to negative 3, and we know that's negative 11 and 8. So then we will rewrite what's inside here to be 11x squared minus 11x plus 8x minus 8. When we do grouping, what would we do next, Leah? Not combining like terms, we split it up so that we can do grouping. So what will we take out of the first half?
11x.
Yeah. Which leaves us with x minus 1. And what about the second half? 8. And that's a positive 8. You have to make sure you have a sign in front of that number. X minus 1. We can see we have the same thing inside those parentheses. So then what do we get? Riley, what do we do when we group? When we're using grouping?
So you just do, you would combine the x minus 1, that would be like x minus 1 squared, and then
So not x minus 1 squared. When we're grouping, we want the same thing in these parentheses. So this becomes one parenthesis, and then we do something else with these terms in front of the parentheses for grouping.
so you just do 11x plus 8.
Yeah.
Okay.
So I'm just rewriting it over here. You can't forget about that 3 up front. So now we were able to factor that quadratic. And this is equal to 0. And by the zero product property, we know that we can set each of those factors equal to 0. And that 3 out front doesn't do anything. Doesn't have a variable with it. So we know x is 1, or x is negative 8 over 11. And this problem is just like 31 as well. In 31, you take a 5 out as your GCF, and then do AC grouping with what you have inside. Questions?
I just want to reiterate that you have to have those steps. I was looking at homework and a lot of people were skipping the second step with the 11x squared minus 11x plus 8x minus 8. You can't skip that step.
So the step I just starred for students at home, you cannot skip that step when you're rewriting this minus 3x, negative 3x. You have to show the negative 11x plus 8x. All right. So now we're going to move on into our notes for today. We are going to be working on page 11 in your note packet. So go ahead and take that out. We're going to look at application problems. So now instead of being just given our quadratic, now we're going to make it from this, what we're given. So page 11 in your note packet. All right. So looking at example 1, it says a town has a nature preserve with a rectangular field that measures 600 meters by 400 meters. The town wants to double the area of the field by adding land as shown. Find the new dimensions of the field. So here they gave us our diagram. When we break this down, the field was originally 400 by 300. That's this right here. We want to double the area of this field by adding land as shown. So we're going to add all this extra land here. And we're going to do that by adding the same amount x to each side. Do we understand this diagram? Okay. So what was our original area of just this 400 by 600? What is that? You may want to get your calculator out. We're going to need them for these application problems. What's 400 times 600? Okay. We took 240,000. And that is meters squared. Just using our meters because we have meters for units, meters times meters. So if our original area of the field was 240,000, then what should the area be of our new field when we add land? What does it say about the area? What do we want to do to it? Faith?
Multiply by 2.
Yeah, we want to double it. So we're going to multiply it by 2. So what does that give us?
480,000.
Good. So our new field will be 2 times this 240,000, which Faith gave us to be 480,000. Good. So now we know what our dimensions of this field are. We want to find out what the dimensions of this 480,000 meters squared field is. How are we going to do that? What's the length of this whole side? Riley?
600 plus that.
Exactly. 600 plus x. I'll write it sideways there. Get myself right. And Riley, what about?
400 plus that.
Yeah, 400. I'll write it down here. 400 plus x. So if the area of that has to be 480,000, how are we going to set up this equation? What's the formula for area? Faith?
Base times.
Yeah, and base times height, length times width, whatever we're dealing with here. So what's our area? What do we want our area to be in this situation?
400 plus x times 600 plus
The area, just the,
x. Oh. 400.
yeah. So 480,000 is what we want our area to be of this field, right? Yeah. So then what is that going to equal? What's our base times height here?
400 plus x. And then 600 plus x.
Yeah, and those are being multiplied. Good. Questions up to there? How we got that? No? Awesome. All right, so go ahead and FOIL. We want to FOIL on the right-hand side here. I'll give you a second to do that. After FOILing, this 400 plus x times 600 plus x, what do you get? Jordan?
I got 240,000 plus 400x
Mm-hmm.
plus 600x.
Yep.
Plus x squared.
Yeah. Good. So then when you combine like terms, what do you get?
240,000 plus 10,000x plus x squared.
So 400 plus 600 is just 1,000. No?
1,000.
You're good. Monday morning. So this is what we get. So now, looking back to your homework problems that you had, we had problems that were just like this, but just with smaller numbers. What do we do to solve for this quadratic, for that x? What should we do? Leah? Yeah, we're gonna have to make it equal to 0. How are we gonna do that? Good. So I'm just gonna flip it. I'm gonna start with my x squared. We have plus 1,000x. And when we subtract that 480,000 over, what did you get? Anyone? Malachi? What are we getting when we subtract this 480,000 over? Good. And this is equal to 0. Now what are we going to do to solve for this x? We need to, go ahead, Brian. Our favorite F word. Yeah, factor. We're just factoring here. So the number in front of x squared is just a 1. So what are the factors we're going to look at? Right?
1,000.
We wanted to add to 1,000, right? What's our C here?
Is it 1 by 240,000?
Yeah.
Negative 240,000.
Exactly. We want to look at the factors of that negative 240,000. We want the factors of that to add to 1,000, positive 1,000. So go ahead and try and find factors of 240,000 that when you add them, will be 1,000.
Wait, negative. Wait. I have one.
Here's a hint. One of them's gonna be 1,200.
200.
Yeah, 200. And our 200 has to be negative there. So then when we're putting it in factored form, what does this look like? This is that quick factoring. Our A is 1 here. We're just putting those factors in. Leah, what would that look like?
M plus 1,200.
Yep.
And X minus 2.
Awesome. We're setting that equal to 0. Using the zero product property, we can set both of those factors equal to 0. So then we would get X equals negative 1,200 or X equals 200. So now we solve for X. So what did X stand for again? X was that additional land that we're adding to each side of this field. Can we have a negative additional amount? Can we? I agree. No, we're not going to have a negative additional amount. So any number that's negative that you solve for, we know that that's not going to be the answer. We know we're not going to have a negative additional amount here. So we know it's 200. So we solved X equals 200. They want us to find the new dimensions of the field for our final answer. So what would our final answer be if each of these X's are 200? Riley?
Would be 800 by 600.
Exactly. 800 by 600, what? What's our unit on those?
Meters.
Meters, yeah. Good. We're going to take that 200 and add it where it says X. And those are the dimensions of our new field, which is what they asked us. So in-depth problem, once you go through and you solve that quadratic, you have to go back and see what they're asking you specifically, how you express your answer. If they asked us just what length you're adding to each side, then you'd have, oh, we're just adding 200 meters to each side. But here they're asking us for the new dimensions of the field. What's 800 times 600? Put that in your calculator. Malachi?
480,000.
Yeah, that 480,000, which is what we said the new dimensions of the field would be. So that's a way to check your answer. Any questions? Faith?
Could you switch them to, like, do 600 by 800?
So you have to look at the way that they gave you the dimensions of the field. So they gave us 600, which is the length here. So Mrs. Kane, what do you say that they?
I'd probably accept either one.
Any other questions? That was a good question. All right, let's look at another example. So now we have a quilt. You have made a rectangular quilt that is 5 feet by 4 feet. You want to use the remaining 10 square feet of fabric to add a decorative border of uniform width to the quilt. What should the width of the quilt's border be? So let's think about what we have here. So we have a quilt that is 5 plus 2x times 4 plus 2x. Where are we getting that plus 2x from? Riley?
Would be the coming from the wait.
the, like, border.
Yeah, from that border, we see that the length is X. For all sides of it, it's X. So if you're looking just at this one side, you're gonna have 2 X's. Good. So they want us to figure out what the width of the quilt's border be, which is X. So what's the length of just the quilt? What's the dimensions of just the quilt part without the border? Riley?
4 by 5.
4 by 5. Exactly. Can't really see that. Mute. No. Okay. But we know it's 4 by 5. So the quilt area is what? We said it's 4 by 5, which we know is 20. How do we think we're going to set this problem up? So we know the area of just this quilt is 20. We want to use the remaining 10 square feet of fabric to add the border. So if the area of the quilt is 20 and the border is 10, what is our total area of this quilt and the border? Faith.
Would it be 30 feet?
Exactly. So our total area is that 20 plus 10. We said is 30 feet. We know our dimensions here are feet. Good. So we know the area of this whole quilt and the border is 30. How are we going to get that 30? Riley?
30 equals 4 plus 4x times 5 plus 4.
Exactly. Because we know the length and the width of the whole border is that 5 plus 2x and 4 plus 2x. Questions on setting it up? Okay. So go ahead and foil here on the right-hand side. And then think about what our next step was once we foiled on the last example. Good. All right. Jordan, can you tell me what you got when you foiled?
I got 30 equals 20 plus
Yeah.
8x plus 10x plus 4x squared.
Perfect. When you combine like terms on the right, what'd you get?
20 plus 18x plus 4x squared.
Perfect. Then what do you do next?
Subtract 30 from 20 and get 0 equals -10
Awesome.
plus 8 plus 4x.
So when we write quadratics, we want our highest power to be written first, so I'm just rewriting it in that way. Questions on how we got to this? When we are factoring, what's our first step? Leah, think back to that cheat sheet. What's the very first step in all factoring problems?
You separate them.
So yes, we will be doing that. But what's even before that? Jordan?
On the GCF?
Yeah, we want to pull out a GCF. Can we pull out a GCF here?
Yeah.
And what is that?
2.
Exactly. Good. Which leaves us with 2x squared plus 9x minus 5. Oops, not. Very nice. Now what do we do? Now that we took that GCF out. Leah, go back to what you were saying. Now what are we going to look at?
You're gonna find what multiplies the 9, but also
Other way around.
add
Add to 9.
multiply.
We have a number in front of that x squared now, so we have to make sure we account for that as well. So it's a times c here. Jordan?
-10.
Yeah, -10. We have a, which is 2, c, which is -5, multiplied together, we get -10. Now of this -10, we want factors of -10 to add to what, Leah?
9.
Yeah, 9. What factors of -10 could add to 9? Riley? Exactly. So now, this step is very important when you rewrite. Why did I choose to have -1 first and then 10? Why did I do that? Malachi, what do you think? So you can think of which way to order those numbers that you put. Faith, go ahead. What were you going to say?
Oh, because you can take out. I just think it's easier to do it that way.
Yeah, whatever way you see is easier to group numbers. I see that that 10 and 5, I can take out a 5 there. So that's what I'm thinking. What numbers should I group together so that it makes sense to take out a GCF? So what should I take out for those first two? Malachi? X, which leaves us with 2x minus 1. And what about for the second half? Faith?
5.
Right. +5, which leaves us with 2x minus 1. We did this right. We got the same thing in those parentheses. When we rewrite using grouping, Faith, what do we get?
X plus 5 is 0. Or x plus 5 and then 2x minus 1.
Yeah. So here, we just had a number being taken out, so that doesn't matter, but you never want to forget about that GCF that you took out. It wouldn't hurt to rewrite it. So then by using the zero product property, you know we are setting each of those factors equal to 0. When we do that, x could equal -5, or x could equal 1/2. Add the 1 over, divide by 2. Which of these is not the answer? Leah? Why? Yeah, it's negative. So we know that x is going to be 1/2. Good, so we solved for x. What does that x mean? Riley?
The width of the border.
Yeah, and what do they want us, how do they want us to write our answer?
Like the dimensions. So it would be 4 plus 1/2 by 5 plus 1/2. Which would just be 4.5 by 5.5.
So close. So when you put that one in, the 1/2 in there, if we're finding the dimensions of the whole quilt, that would just be 4 plus 1, because 2 times 1/2 is just 1, and then 5 plus 1. But here, they're asking us just what should the width of the quilt's border be? And what is the width of the width of the quilt's border represented by here? Okay,
4 plus 2x
so that's the length of the whole side.
and 5 plus 2x.
That's the length of the whole width. What just represents just the border? Riley?
4 x.
Yes, X. Just X is the width of the border. Yes, when we look at one side, we would count 2 X's, but they're just asking what the width of the quilt's border is, and that's just X. So our answer is just 1/2. And what's our unit here? Leah? Feet. Good. So then you could write the width of the quilt's border. Just to specify what that 1/2 is. So our width of the border is 1/2 foot. You could also say 6 inches. Questions on this one? So it's always very important to look at what they're asking specifically out of this problem, how to write your answer. Okay. So let's look at the next problem. Let's think of how to just set this up. So here we don't have any diagrams, so we got to make that. It says a pool deck of uniform width is going to be built around a rectangular pool. That is 20 feet long and 15 feet wide. After the deck is built, a total of 414 square feet will be occupied. How wide is the deck encompassing the pool? So let's look at that word, uniform width. And that's for the deck. If we look back to the last problem, they're talking about the border of this quilt of uniform width. And it was the same width along the whole side, every side of this quilt, uniform width. So that's going to be the same for this pool problem. We're going to have this pool in the middle and a deck around it of uniform width. It's the same, the border of the pool, the deck, is going to be the same width on all sides. So we have this pool, which they said is rectangular. We have this deck around it that's of uniform width. So I'm going to just call that X. The same around the whole pool. This deck is X width around the whole pool. What else do we know about this pool? How else? What other things can we label on this diagram? Malachi? Yeah. So we know that this pool length right here is 20 feet. And we know that it's 15 feet long. What's the length of this whole length of the pool and the deck? 8.
15 plus X. 2X.
Yeah, so 15 plus 2x would be up here. So I just labeled this side to be 15. And then,
20 plus.
perfect. Because we know we have another x there. What's the area of the whole pool and the deck? Riley?
414.
Exactly. So the area of the whole pool and the deck is 414, and what would that equal? What's the length times width of this whole pool and deck? Leah?
15 plus 2X times 20.
Exactly. So we set up the diagram and we set up how we should solve, and we know what to do from here. We would FOIL, set it equal to 0, and factor. So we are about to be out of time. Your homework for tonight is a factoring and application worksheet. It's on Google Classroom. So the first page is just practicing factoring. Make sure if it's on here. Just practicing factoring. And then the second page is application problems. And they don't give you the diagrams for those. So look at these to find similarities on how to help you how to set up the diagrams. The diagram is the most important problem of these problems. Once you know the diagram, you can figure out how you should solve. Questions? Cool. All right, so for students at home, make sure you take that daily attendance, and the homework is on Google Classroom. Have a great day.
Bye, have a good day.
You too. Yeah, because it's 8:05.
You guys can go. Grab some sanitizer on your way out.
Have a great day. Cody, do you have any questions? You too.